Hi everyone, my name is Andrew Wright, and today I'm going to give a quick recap on my 2023 summer undergraduate research and economics project. So for this project, I decided to look at state level exports within the US and how these state level exports change based on changes in the real exchange rate. Specifically, I looked at oil, mineral, and chemical products, and I looked at exports to China, Mexico, Japan, and the UK. So the purpose of this analysis was to expand previous literature that looked at how country level exports are impacted by changes in the exchange rate. Most previous authors have found that country level exports are changed by changes in the real exchange rate, whether that be appreciations or depreciations of the home currency relative to the foreign currency. So specifically, I wanted to expand this analysis to state level exports, and I wanted to look at additionally how trade diversification matters for this relationship. Specifically, does trade diversification mitigate the impact of changes in the real exchange rate on quarterly exports? And again, I looked at oil, mineral, and chemical products to just kind of have a smaller case study of specific product categories. So there's definitely room for future research to expand this to more product categories. So for this analysis, I decided to use first difference panel data models. And so this is my baseline model where this SCT represents quarterly oil, mineral, and chemical products from state S to country C in time period T. And so I'm using quarterly data, quarterly US data from 2010 to 2021 for this analysis. This E star represents total quarterly exports less oil, mineral, and chemical products for state S to country C in time period T. I also decided to include the spot price of crude oil um, that's given by the U.S. Energy Information Administration. I also included this delta T component as a dummy variable that's meant to control for some time effects. So most of these product categories, especially oil, obviously have large seasonality um, in the volume and the total value of exports. So that's meant to kind of control for some of those seasonal components. And this last component is another dummy variable that's meant to capture each state and country combination. So, for example, this can represent um, Wyoming exports to China or Colorado exports to Canada. So that is the baseline model. And then from there, I decided to expand on that model. So the first expansion is including a measure of the real exchange rate. And I decided to use a measure that is found in this paper by House and their co-authors in 2019. They basically define the real exchange rate as the change in the nominal exchange rate between the country and the US, plus the change in the CPI between the country and the US. Um, and they trade weight this sum by the ratio of the state's total exports to its GDP. So the purpose of using this measure is it allows for each state to have their own specific real exchange rate between them and between that state and the export destination country. So that is the first model. And I also included this interaction term. This is what really gives us the state and country specific effects. So this this will give me um, a coefficient estimate for each state and country combination. The next extension was to include a measure of the number of trading partners for each state and each quarter. Um, so this is that TP term. And I defined this term as the unique number of export destination countries for each state and each quarter. And it includes all product categories. So for example, if this was 11 for Wyoming last month, I said that that meant that Wyoming exported to 11 countries, 11 unique countries last quarter, and includes, again, all products, not just oil, mineral, and chemical products. So that is um, the next addition as compared to that baseline model and that second model. And I also included the interaction term, um, the same interaction term as the last model, though I added the change in the number of trading partners to see impacts, how this reacts to changes in the real exchange rate when looking at specific state and country combinations. And so the last model I decided to look at just used a different measure of the real exchange rate. It's similar to the one found in Ellis 2001, where it's just the nominal exchange rate multiplied by a ratio of prices between the country and the US. And I also trade weighted this measure with the same trade weight component, ratio of a state's GDP, or sorry, ratio of the state's total exports to its GDP. So this is the same. This model looks the same as the last model, except that I decided to just change this measure of the real exchange rate to see how changing um, the real exchange rate measure impacts the empirical results. Um, Additionally, I decided to to use a first difference model just to help us interpret the results a little more easier to get everything into the same units because we're working with exchange rates, trading partners, crude oil prices, and total value of exports. And we're looking at changes just to make sure that, again, everything's in the same units so we can kind of compare our results easier. And so these are the empirical results of the baseline model. And again, the purpose of the baseline model was to choose predictors that at least I thought would be statistically significant in terms of explaining quarterly oil, mineral, and chemical products. Obviously, I was a little I probably should have chose a different measure for um, the price level. I should have chose something that included chemical and mineral products as well. I thought that oil products would make up uh, such a large portion of the state's exports that it would explain quarterly oil, mineral, and chemical products. But at least in this baseline model, it was not a statistically significant predictor. It was in subsequent models, which is a little interesting. When I decided to include the real exchange rate measure, for example, it ended up being a statistically significant predictor. But if I were to return to this topic in the future, I would like to change this to some kind of price measure that captures chemical and mineral products as well, in addition to just the crude oil price. So looking at the actual results of that second model, which is the first expansion of the baseline model, where I included the real exchange rate calculation based on um, that House et al. Paper. And so here I'm just showing the results in heat maps. These are um, the coefficient estimates for the interaction term. So this is the interaction between each state-country combination and the change in the real exchange rate and how that impacts quarterly oil, mineral, and chemical exports. The green states are where there is a positive correlation between changes in the real exchange rate and quarterly oil, mineral, and chemical products. And the red ones are where there is a negative correlation. And I outlined, it might be kind of hard to see, but I outlined the statistically significant results in yellow. So looking at, in this case, the UK, it'd be Maine and Hawaii. And I just assumed p-values less than 0.05 were statistically significant. So these are results for that first model, the first extension of the baseline model, where I included the measure of the real exchange rate from the House paper. Overall, there's definitely a lack of statistical significance. So I'd say based on this measure, based on that measure of the real exchange rate, it doesn't explain quarterly oil, mineral, and chemical products, at least in this time period, 2010 to 2021. Looking at the results of Model 3, there's slightly more significance. This is where we included the number of trading partners in addition to that same exchange rate measure from that house paper. Um, so, for example, we look here at the UK, Colorado, New Mexico, Hawaii, and some East Coast state. Um, but overall, it's still not, there's not a whole lot of states where the number of trading partners impacts the real exchange rates effect on quarterly oil, mineral, and chemical products. So overall, it doesn't appear that diversification has any impact on how states' trade patterns are impacted by changes in the real exchange rate. And these are the results for the last model, where I used a different measure of the real exchange rate based on that Ellis paper. Again, there's not a whole lot of statistical significance except looking at Japan in this time period. There's a fair amount of states where the number of trading partners and the changes in the real exchange rate using this measure do impact quarterly oil, mineral, and chemical products. So I thought that was kind of interesting. And for the most part, this model resulted in more positive correlations between real exchange rates, trading partners, and the quarterly oil, mineral, and chemical exports as compared to the previous models. So, overall, I would say that most state level oil, mineral, and chemical exports were not impacted by changes in the real exchange rates from the period 2010 to 2021, at least using the two measures of the real exchange rate that I used. And overall, the number of trading partners doesn't really change how states react to changes in the real exchange rate. Again, you have to kind of remember that these results are specific to these measures of the real exchange rate. So there's definitely room for future research to see how these results change when we use different measures of the real exchange rate. And I'd like to thank the economics department at the University of Wyoming for allowing me to do this research project over the summer. Thank you to Professor Skiba for his helpful encouragement and advice on this project. And I'm very thankful for this opportunity to gain a glimpse at how empirical research is conducted in the field of economics. And those are the two papers that I used in case you want to look at those. Thank you.